sometimes I just forget about recording. And I do want to mention that we are getting to the last 3 weeks of classes. So the last assignment is on ER. I already put it up last week, and I will make, yeah, that's anyway not an online kind of assignment. It has to be written down. So you have to put it in some kind of PDF file. And we are also getting to the last of the few quizzes. So there'll be a quiz on ER this week, and then maybe I'll give a quiz on constraints and indexes. I haven't kind of figured out. A lot of the stuff like I'm doing from this point onwards are really stuff that you have to try out on the yourself, like a lab, and try them out. So yeah, so let me just get back to what we were doing in the last lecture. Okay, so we were talking about constraints, and so I was talking about foreign key violations. So, so we're talking about this particular example, the department and the employee table, and the manager's social security number is a foreign key which references the employee table. So if you try to enter a manager's social security number that does not exist in the employee table, you're going to get an error. As a programmer does not have to check this. It's automatically done by the schema. So we were, so the default action, like I mentioned in the last class, is restrict. If you, so restrict is, it's not allowed, you get an error message. But so this is in the department table. So when it comes to a department table where you are referencing the employee table, the only possible action is restrict. But in the employee table, you can do more than just restrict. So you do have the restrict, which is a default, but you can also do set null and cascade. So this is where I stopped in the last class. So I just want to continue with this. So let me show you how this works, the set null and the cascade. So we have, okay, and then we have the manager social security number. And then we go down to the foreign key constraints. So okay, so normally this is where we ended. We just state that foreign key manager social security number references employee social security number, and in MySQL, the social security number has to be a key in the employee table, but we can add on more to this. So now I'm stating on delete set null on update cascade. Okay, so what happens when if you write this down in your schema in the definition of the department, what this means is that if from the employee table you delete, so let's say we have a manager's social security number is 1234, and then we decide to delete the employee 1234 John from the employee table. If that happens, what happens is that you're not going to get an error. What will happen is that when you delete 1234 from the employee table, the value of the manager social security number 1234 in the department table will get set to null. So you're not going to get any error or something, but what it does is that it will set the value to null. So that's the meaning of set null. So which means that you can actually now delete from the employee table. It's not going to create an error. So that's the set null. The cascade means that just suppose that, that the social security number 1234 was actually a mistake, and I update the social security number to 1233. So when I update the number from 1234 to 1233 in the department table, the social security number will also get updated to 1233. So again, this is nothing that any data entry operator has to do or a programmer has to do. All of this will happen it all happens together. If it gets updated in the employee table, it'll get updated in the department table. If it gets deleted in the employee table, it'll be set to null in the department table. So, so that's the, so that's an option. So besides restrict, you could also just do set null or cascade. So let's look at an example. I just want, because since I can't show this to you on the, I'm going to do a smaller table. So example.
With the restrict, does it prevent the null from being entered in an insert?
Restrict is the default action. That's what, if you, at all the schemas that are given you right now, it's all restrict. You don't have to write restrict. It's a default action. If you don't write anything, it's restrict. And what happens there is that if I deleted 1234 or I updated 1234 in the employee table, it'll give me an error. It won't allow me to either delete or update that, because there is a manager with that social security number 1234. So it's a default. And so if you want to restrict, you don't have to write restrict. It'll do it by default. So let me just, give us, and this, hopefully it'll get clearer with this example. So we have this table R. So again, I'm going to have to use really with two columns, A and B. And then we have this table S. And you're given that for this table, you're given that foreign key CD references primary key. So really what I'm showing is that C and D are referencing A and B. So the key for R is AB. Okay. And on delete, cascade, on update, cascade. So this time I'm not saying on delete set null, I'm saying on delete cascade and on update cascade. So that's the thing. So I'm going to put a really small table. So we have R. So suppose I have an R11, 21, and 32. And now I have the table S. And has rows C, D, E, and F. And suppose I have 1, 1. Okay, so S has the following 4 rows. Okay. So suppose I decide to delete. So it's stating out here on delete cascade. So suppose I decide to delete 1, 1. So I'm deleting this row. So what's going to happen is that the corresponding, so there's 1, 1 from here, these rows will also get deleted. So this is not something that you have to do. This is all done. The moment you delete 1, 1 from R, it will delete those first 2 rows in the table S. And this is going to all happen as one unit. If the row is deleted from R, then the row will be deleted from S. And that's the way it is. It's never going to be possible that it'll get deleted from R and not be deleted from S. And so again, so now let me show you with update. So and suppose I'm saying on update cascade. I could have also said on update set null, but I'm going to say on update cascade. So here, suppose I change from 2, I change the key to 7. And the moment I do that, the same change will happen in this table too. So that's what it means. Um, there are things that you can, if you make changes in R, it'll get reflected in S. You're not going to get an error. So did everyone understand this example? Yeah. So again, like I said, these things, just try it out on your employee data, on the company database, and that's the best way to understand. It is actually relatively easy. So, but it's still a good idea to try it out. Let me give you one more example. Okay, so which of the following is guaranteed to not give an error? Or in terms of, you know, um, I mean, and I say guaranteed, I also mean in terms of what we're talking, this foreign key kind of stuff. In that context, so please see it in that context. Which of the following is guaranteed to Okay, so suppose we have these two tables. We have table R with, again, with AB, and we have table E with C, D, E. And so in this case, I'll just say the foreign key D. So let's connect this one. So A is the key here. So we have foreign key D is referencing A. Okay, so I'm going to give you 4 options. Insert into R. Oh, this should be S. Insert into S. Delete. Say delete from S. Update R. So out of these 4, which of these, if when you do an action, are you guaranteed that you're not going to get any kind of foreign key violations? So anyone, what about insert into R? Could that give you a foreign key violation?
No, you'll be good then.
Yes, so that's right. For insert into R, you're never going to get any issues. What about insert into S?
That one you could, if I think, if you tried to do a is a D value that wasn't in it in R.
Yes, so that's right. So you could get an error with insert into S. What about delete from S? Would that give any error, foreign key violation error?
No, you'd be good there.
Yes. And then finally, it's update R, which you could get an error because if you try to update um, something that um, belonged to S, then you could um, get an error. Trying to see. So is it this? It does. Do you understand? Did everyone understand this example? These two examples. Okay, so I mean, really, these are the type of questions I would give in a quiz or a exam along these lines. Um, so that's why I want you to try it out. There's really no assignments I can give. There's only very simple stuff that I can give. Nothing that should take too long to do. So then I just want to add. If you wanted to add a constraint after a table is created. So I just want to give you some of the SQL things. So if you wanted to add a constraint after the table is created, the command that you would give is alter table, let's say dependent. So if you wanted to name the constraint, and it's not necessary, so that's why I'm going to write it in a different kind of color because it's not really an essential. If you wanted to name it, you could name it. You can call the name as constraint. So I'm calling the constraint dependent SSN. Okay, so but it's this is a optional. Naming it is optional. Then you can say add foreign key ESSN references employee SSN on update cascade on delete cascade. So if I add, so once you defined everything, you can add this constraint called dependent social security number later by just adding this to the table. So after this, if I did this command, update employee set social security number is equal to 1233, where social security number is equal to 1234, it will cascade down to the dependent table. Or if I gave this command delete from emp where social security number is equal to 1233, then it'll also cascade down and delete the dependents of the person with social security number 1233. So you can add later. So if you wanted to see unnamed constraints, so this was to add, so to show So if you, in order to delete a constraint, you have to see, you have to give the name of the constraint. So when you do not name a constraint, so if I do not name this constraint out here, the system will automatically create a name for it. And so when you want to delete it later, you'll have to find the name. So if you want to see the unnamed constraint, or all the constraints for that matter, you can just give this command, show create table dependent. So this will show you all the constraints. And then if you want to delete the constraint, because you have to use the name to delete. So drop constraint dependent social security number, and it'll drop it. It'll delete it. So I think these are the only commands that are there that deal with constraints. So in MySQL, that's about it with constraints. It doesn't really have that much more. I think it really just has these foreign key constraints. But there are other kinds of constraints that are very useful in most other databases. So I'm going to talk about them very briefly. So even though they're not available in MySQL, I think they are, it's useful to know about them. So attribute-based constraints. And again, I just want to just make sure I don't want you to try it out in MySQL, because you will, so it's not available in MySQL, but it is available in most other databases. Okay, so let's just go back to the department table. So create table department. So D number, integer, not null. Okay, so now I'm going to add a constraint to this. So I'm going to call, so this is again the name, and it's not necessary to give it a name. If you don't give it a name, the system will number it. So let's call the constraint department number constraint. And then the thing is check D number is greater than 0 and D number is less than 10. So if you add this constraint in the table definition, then anytime department is, when you department number, you add, delete, or update, anytime this department number attribute is affected, you touch it in any form, this constraint is checked. So it's always checked. So it is actually very useful, and very useful feature. So it's a pity it's not available in MySQL, but it's a very useful feature. It's a pretty common feature too in other database systems. So this is just with an attribute. You can do this with any attribute. Similar to this, you have also constraints that touch the whole row. So So if you have more than one attribute participating in the constraint, then it's called a tuple-based constraint. So again, as an example, so we have create, say, table works on okay. So then I'm saying check. Let me write that in a different color. Okay, so whenever you update any row, so this one is really saying that if they are not working in, if the project number is anything other than 1, then the number of hours you work on it has to be greater than 20. So you can add constraints like that. So it's checking the, so it doesn't just, it checks the entire row as a unit. So again, it's a very useful one. And then the last of these are if you attribute tuple, and then you have interrelation constraints. So I'll just, as the name says, this is now constraints at connecting two tables together. So let's look at this one. We have create table department, and then check mgr ssn in select ssn from employee, where d number is equal to d number. Okay, so this is really checking when you add or do something to manage a social security number in the department. It'll make sure that whoever is a manager is also is working in the same department. So it does the check. So it's it's just really something that as a programmer you don't have to have a check. It's right there in the database. So does anyone have any questions about constraints? So please try this out. That's the only way of learning. And like I said, it's a pity that MySQL does not have the interrelation, tuple, or attribute base. But I would like, since I definitely want you to be aware of it. It's a very powerful feature of databases, and SQLite and Oracle database and all, they all have this feature. So it's good to know about it. So the next thing, so that's it with constraints, but I'm going to move on to the next topic, which is really triggers, which are they're more powerful than constraints. And again, triggers are, so since they're more powerful than constraints, they're a very useful feature. So this is chapter 26.1 in your section 1 in the new edition and also in the old edition. So similar to constraints, they're called triggers because they are fired or executed when an event which is insert, delete, or update. So they're so whenever an insert, delete, or update happens, it will check this trigger, and triggers are, it could be over the entire database. So it'll check the trigger condition, and if it's true, it does an action. So it's actually, like I said, they're just like constraints. So if true, it'll do the action. And again, they are implemented, like I said before, they are implemented in the schema just like constraints. So and then they're more powerful than constraints. So every constraint that we have done so far, you can do them. You can also do them as triggers. So I'm going to give you the syntax first. So syntax is create. Triggers are just mini programs actually that you have to write into the schema. So create trigger, and then you give the trigger name. So every trigger, you should give some kind of user-defined name, and then and I'll explain each of these before. Oh, after the event. On table. Condition. Action. So that is the syntax, create trigger, then the name of the trigger. So the name is any kind of, you have to give the name. So user defined name. Event is always insert into T, update T, or delete from T. So those are the events that are there. And then these action out here are all SQL statements. So it's really a program that you are inserting into the schema. And I also want to definitely mention out here that this one thing, this when condition is not there. This is not there in MySQL. So I'm going to explain triggers just using examples. So the first one I'm going to show is how, remember I said that every constraint that we have done so far, you can also write it as a trigger. So I'm going to do a foreign key constraint and write the foreign key constraint as a trigger. So so the cascade option for, so when you delete, I want it to be cascaded down. So the example I'm going to use is again for dependent dot ESSN. So the dependent is the foreign key ESSN to the employee's SSN. Okay, so instead of writing foreign key dependent references employee, I'm just going to write dependent ESSN to employee SSN. It's just a shortcut instead of writing all that down. Okay, so now let's write the trigger. So we say create trigger. Okay, so let me call this department foreign key. So now we have the before and after. So after delete on employee. Okay. After delete on employee. For each row, delete from where ESSN is equal to, and so now this one I'm just going to write down where ESSN is equal to, so you haven't seen this before, old dot SSN. Okay, so this is the way you would write the cascaded delete constraint. So we have create trigger department foreign key. So that was the name that you're given. So after delete on employee for each row. So once you delete, so what after out, what the meaning of after out means that after you carry out the action of delete on employee, then you go down to the dependent table and you check row by row. So you check in the dependent table. So because you just deleted, that's why this is called old, because this is the row that we just deleted. So it's actually, that's the reason it's called the old dot SSN. So delete from dependent where ESSN is equal to old dot SSN. So that's what the old refers to. So it refers to the tuple that was just selected for delete from employee. So that's the old dot SSN. So if you gave this command afterwards, if you said delete from employee where SSN is equal to 1, 2, 3, 4. If you said that, if you gave this command, then it will delete all the dependents of 1, 2, 3, 4 from the dependent table. So this is doing exactly what the foreign key cascaded delete did. Any questions? Did you understand this particular example? Okay, so this was example 1. So let's do another example. Let's do okay, so create trigger dependent update after delete on employee for each row. So I just want you to look at this and see if you understand this one. So update dependent, set ESSN is equal to 9876. Because I know that this is a query that doesn't really naturally make that much sense. So what we are saying is that if I delete from employee, wherever, if I deleted 1, 2, 3, 4 from the employee table, I'm going to set the ESSN of the dependent to 9876 from 1, 2, 3, 4. So just wanted to show you an example with where I'm updating. So I hope you understood these were two examples of triggers that are doing exactly what the foreign key constraints are doing. And if you have a constraint, so in your database schema in general, there are constraints and then there are triggers and then so constraints have higher priority than triggers. So I hope I'm correct because it's been a while since I checked. Yeah, in general, constraints have higher priority over triggers. But I should double check this. Okay, so now let me give you a more, so far the triggers have only done what constraints have done. So I want to show you an example of a trigger that does more, far more than what a constraint can do. So let's look at the next example. Okay, so we have actually, now it's 9:56, so I think I'll just start up this example in the next class. So this is an example where the trigger is going to connect the employee table and dependent table. So I want to do an example which will, so yeah, something that so far we haven't been able to do in SQL. With the stuff we've done. So I guess I'll show you the example in the next class. So does anyone have any questions? So in the next class, there will be a quiz and the quiz will be on ER diagrams only. So it won't be on constraints and it won't be on triggers. It's just going to be on ER diagrams. And I have put up in the assignment. It's under the files/assignment folder. So take a look at that. The quiz will be somewhat along those lines. So you should maybe take a look at the assignment while studying for the quiz. So any questions?